Okay guys, so as I said in the last question video as well, this is a question we did today, but the recording got messed up, so I'm re-recording it at home now. 2012 V3. So we are given one equation with two logs in it. Log 10x minus 5 equals 2 log 3x minus 4, and we are asked for what values of x are the logarithms in the equation defined. So we need 10x minus 5 to be more than and not equal 0, and we need 3x minus 4 to be more than 0, because we can only put positive non-zero numbers into log. So that makes that one, and then that one makes that one. So we get x must be more than a half, and x must be more than 4 over 3. Now this is where we stop. Please note the question says, for which values of x are the logarithms in the equation defined? The plural there is very important. It means we stop here. If the question said, for which values of x is the equation defined, singular, is the equation defined, that changes what we have to do. It means we have to put these two conditions together into one condition. So if that was the case, we would have to say x is more than 4 over 3. Because when x is more than 4 over 3, it is also more than a half. So both are automatically true. This is the only way to make both true at the same time. But that's not what is asked for here. It's just worth noting. Okay, second part now is to actually solve this equation. So to solve, we want to solve log 10x minus 5 equals 2 log 3x minus 4. Well, we can't cancel the logs because we don't have log on both sides. We have 2 log on the right. So what we do first is bring that 2 up to the power. And now we have log A equals log B. So now we're allowed to cancel the logs. On the left, there's nothing to do. On the right, we can expand. 9x squared minus 24x plus 16. This will be a quadratic. The quadratic is 9x squared minus 34x plus 21. We can factorize this, equals 0. We have x minus 3 and 9x minus 7 equals 0. So x equals 3 or x equals 7 over 9. But we reject this answer here. Reject. And we only accept the answer on the left. And the reason for that is, if you go back to the first part, we need x to be more than a half and more than 4 over 3. If we try to use 7 over 9, it's no good. It's not more than 4 over 3. It's actually smaller than 4 over 3. So this equation will only be defined if we use x as 3, because x, if it's 3, is more than a half, yes, and is more than 4 over 3, yes. Okay, so that answers the A part 2. Now it's the B. So we have this function Vt equals AEKT, and we don't know the AK constants, but we do know that when t is 7, V will be 75, and we do know that when t is 12, V will be 170. So we can sub both of those points into our equation to make 2 equations. So we end up saying 75 equals AE7K and 170 equals E12K. What is the best method to solving these two? Well, we can use substitute. Oh, sorry, I left out my A here. We can use substitution to solve these. We can get a out from the first equation and put it into the second equation, that's fine. But there's a nice trick here to combining these two equations together to make it into one simpler equation. We can say AE12K equals 170. We can also say AE7K equals 75. And we're allowed to divide these equations because they can never be 0. E can never be 0, and 170 and 75 certainly aren't 0. It's possible here that the A is 0, but when you look at the numbers it can't be 0, so it's actually impossible. So we're allowed to divide these equations together. And you might say, well, that equation looks a lot more complicated than the two equations we had a moment ago. But you realize a lot of things cancel here. These A's go, and when we have these E's divided, we can use the second rule of powers. Division of power. Division means subtraction of powers. So 12k minus 7k is 5k, and that's 170 over 75. So we can get the k out from this. We can cancel the e by putting a log on both sides. So when we log on both sides, we cancel and we're only left with 5k on the left. And then we can cancel the 5 by dividing by 5. So we end up with k equals that big thing we have to type in on our calculator. So we need to type in log 170 over 75 all over 5, and we end up getting k equals 0.1637. We can put that k back into, say, this equation to get us the a, because now we know then that 75 equals AE, I think it was, 7k. 7k. So this means that A will equal 75 over e power 7, 0.1637. Okay, so fraction 75 over e to the power of 7 times the answer we just got for k, and I end up getting here for a equals 23.85. So we have the a and k. That's part 1 done. Now on to B part 2, is find the v when t is 15. So we get v equals AEKT. We know the a, it's 23.85. We know the k, it's 0.1637, and we know the t, it's 15. So you get 2 marks for just typing this in. 23.85 times e to the power of 0.1637 times 15, and that comes out to be 277.9. So if we go to 3 significant figures, it would be 278. So I'll just leave it as 277.9. Okay, and that's that question taken care of.